Today I'll discuss how to find mean uh, of Poisson distribution. Poisson distribution, one of the most important discrete type of distribution. Okay. Now please write down the question. Find the mean of Poisson distribution. Okay. First you write down. Now you write down this proof, or you may write answer. Okay. So if you want to find the mean of Poisson distribution, first you need to write down the PMF. So please write down the PMF. The PMF of Poisson distribution is P x equals to I e to the power minus lambda to the power I by factorial I, where I is equals to 0 1 2 3 dot dot up to infinity. Okay, so this is the PMF. I think you are thinking what is the full form of PMF. PMF full form is probability mass function. Probability mass function is a very important part. Okay, probability mass function. So this is the PMF. P x equals to I is equals to e to the power minus lambda to the power I by factorial I, where lambda is a constant. Okay, where lambda is a constant. Okay, clear? Next you write down mean. You want to find mean. So mean is equals to E of x. This is the formula. So here you may write what is the general formula. I is equals to minus infinity to plus infinity I p x equals to I. So this is the basic formula. Okay, so our in my next step we should replace this part as for PMF. Clear? In my next step, so I will replace Px equals to by this. Is it clear? Okay. So what about the last line? Sorry. What about the last line? You have I is equals to minus infinity I p x equals to I. So already you know this is the PMF of it. Okay. So what is the PMF for Poisson distribution? You may write I is equals to, first you write down this, then you can understand, e to the power minus lambda to the power I by factorial I. Is it clear? Now you can see when you are replacing, what is your Px equals to I? E to the power minus lambda to the power I by factorial I, where I varies 0 1 2 up to infinity. Correct? So when you are replacing PMF as per your Poisson distribution, the range will be 0 to infinity. Your range will be 0 to infinity. Is it clear? Because in the general formula is I is equals to minus infinity to infinity, but when you are replacing Px equals to I by PMF, then as per range of I you should replace. So that means from here it is clear 0 to infinity is coming from here. Okay, Good. I think it is clear. It's a very, very important line. Very, very important line. Now, so from here it is clear this range is connected with I. Okay. So this term and that this term all are connected with I. But this term is not connected with the I. So you may take it outside e to the power minus lambda. So here you may write I is equals to 0 to infinity I lambda to the power I by factorial I. Now I think it is clear. Now in next line e to the power minus lambda. So here what I'm writing, listen carefully, lambda to the power I by I factorial I minus 1. So already you know from your earlier class, suppose I have factorial 3. What is the factorial 3? It is nothing but 3 2 1. So you may write 3 factorial 2. This can be written as 3 factorial 3 minus 1. Is it? I think it is clear. Okay, same way. So here you have factorial I. So you may extract I and I minus 1. Okay, so this I and this I are cancelled. Clear? So here you need to write I is equals to not 0. Be careful, not 0. So you should write 1 to infinity. Is it clear? Because if I write 0, then 0 minus 1, that is negative factorial, which is undefined. So that's why you should write I is equals to 1 to infinity. So that's why please write this line is also very, 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 very important. So these are the key line. Okay. Is it clear? Okay. So now in next slide, try to next step, try to understand our objective to replace it. So e to the power minus lambda, lambda is equals to 1 to n, sorry, 1 to infinity. So here you can see in factorial you have I minus 1. So I should write lambda, lambda to the power I minus 1 by factorial I minus 1. Is it clear? So here why I am writing, because our objective to rewrite I like I minus 1. So already you know, if I have I, yeah, lambda to the power I, in my next line I have mentioned that is lambda, lambda to the power I minus 1. Clear? So what is the power? Power is 1. If I simplify, it is coming lambda to the power I min plus 1 minus 1. So ultimately it is coming lambda to the power I. Clear? So that's why I am writing. Is it clear? Okay, very good. So shall I move to the next? Okay. So now, so you have e to the power minus lambda summation I is equals to 1 to infinity lambda, lambda to the power I minus 1 by factorial I minus 1. So here I have added 2 to 3 line extra especially for your better understanding. Okay, now you can see this lambda is not connected to the I, you can take it outside. So e to the power minus lambda into lambda. So how much you have? I is equals to 1 to infinity lambda to the power I minus 1 by factorial I minus 1. Now you put I minus 1 is equals to capital I. So when I is equals to, when I is equals to 1, when you put I is equals to 1, I is equals to 0. When I tends to infinity, this one. So your I, capital I is also goes to infinity. Now we are replacing it e to the power minus lambda, lambda summation capital I is equals to 0 to infinity lambda to the power I by factorial I. Okay, is it clear? Okay, very good. So now, so already you know that what is your e to the power x? E to the power x is equals to basically 1 plus x plus x square by 2 plus x cube by 3 factorial 2 factorial 3 plus dot dot up to infinity. This this expression, that is an infinite series, this series can be written as I is equals to 0 to infinity x to the power I by factorial I. Clear? So if I write I is equals to 0, so first term will come. If I put I is equals to 1, then your second term will come. So here you have a summation, that is double term you will get it. And if I put I is equals to 2, then I will get the third term and so on. So from here it is clear, if I have any value, if I can see this, then we can write this expression. So here you can see this expression and that expression is same. So here you may write e to the power minus lambda, lambda e to the power lambda. Is it clear? So basically small I, capital I, more or less same. Only thing is different, that is your x and lambda. So if I have this expression, then you can write to the power x. Same way, I can write lambda to the power lambda. So these two are cancelled because already you know a to the power minus 1 is equals to 1 by a, isn't it? Same way, you may write 1 by e to the power lambda into e to the power lambda. So these two are cancelled. So ultimately you have lambda. So here you may write therefore mean is equals to E of capital X is equals to lambda. So this is the mean of Poisson distribution. Is it clear to all of you? Is it clear? So here already have explained that these are the two key line and last key line is here. How to replace it? Clear? I think it is clear to you. Okay. Thank you. Thank you everyone. Please do subscribe my channel, and if you can see any benefit from here, please inform to your friends also so that they can also get some benefit from this video. Okay. Thank you. Thank you everyone.